Okay, so today's lecture is the last lecture on I/O, on input-output. I want to show you how to read formatted input today, or formatted data. So many types of files contain line-oriented formatted data, right? But many types of files don't. Right? So many types of files are formatted, but they're not line-oriented. So any programming language that you work in, it consists of formatted text, right? The text has to have a certain structure to it, right? These data exchange, well, JSON's a data exchange format. So JSON's a very common data exchange format. It's JavaScript object notation. That's basically, so that's a data exchange format that's not line-oriented. XML and HTML, these are two other formats, two other common formats that are not line-oriented, right? These are all tag-oriented. Right, so in HTML, you've got an opening tag and a closing tag and stuff in between. So these are generally more difficult to read than line-oriented formatted data. If you want to see a little bit about how you go about parsing or reading one of these files, you can hit that link there, which is a very nice overview of parsing algorithms. It's not something you normally do in undergrad anymore. If you do it, the only place you'll do it is in your compilers course, which isn't until fourth year, and it's not always offered. So I want to parse a line-oriented formatted data file today. So let's look at the file called etc password, which used to actually store your password data, but it doesn't anymore. OK, so cat password. OK, so that's an example of the password file on, hang on. Okay. That's an example of the etc password file on my computer. So you can see, if you look closely, you can see it's got a bunch of text, but it's separated with colons. Right? So this is an example of a colon-separated file. The content of the file, oh, I should tell you something else. So that X right there, many years ago, that actually used to be your password. Hopefully, it used to be your encrypted password. So it would be sitting here in this password file that anybody can read. Right? So etc password is readable to the world. So that X used to be your password. The password is no longer stored there. And that's usually always an X on a modern Linux machine. Your password's actually stored in this file called shadow. So it's etc shadow. So there you can see that huge string of text that goes all the way to that colon. That's your encrypted password. Right? So somewhere the operating system's got a key to, not somewhere. So you can unlock that if you have your actual password, right? So that's all. Yeah. So that's all I want to say about that. So I want to parse that etc password file, right? So that file is just it's really just a simple database. So all it does is it lists information about authorized users on your computer, right? Now, an authorized user doesn't have to be a person. There's a bunch of processes on in the operating system that the OS also considers users, right? In fact, most of those things that I showed you, they're not actually people. They're actually processes on your computer, right? So there, that one. Right. So for example, what do we have here? Right. So UUIDD, that's the universally unique identifier daemon. Right. So that's the thing that sits on your computer and generates universally unique IDs. Right. Pollinate in Ubuntu is the thing that what does it do now? I forget. Oh, Pollinate generates random numbers. So it goes out onto the internet to a server and grabs a random number from there. And of course, I'm on here, so there's my user. But there are all these other things here. These are just processes on the computer that the operating system considers to be a user. Right? LP is the printer daemon. Man is the man daemon, and so on and so on and so forth. So this file has a very specific format. So it's plain text, one record per line. Each record has 7 fields separated by colons. So there's an example of an actual user. The first field is the username. The next field is used to be the password. It's now always an X, almost always an X. User ID, which is just an unsigned number. Group ID, which is an unsigned number. This can be anything. the next field. So that's the GCOS field. That's a historical name. That's basically user information that you're allowed to embed here. So you can put things like the person's actual name, their contact information, whatever you want, right? That's their home directory, and that's their login shell, right? So that's the shell that they get when they log into the computer. So always 7 fields. Now, the individual fields are not allowed to contain colons, right? So you don't have to worry about, for example, the home directory having a colon in it, right? If you try to create a home directory where there is a colon in it, then you won't be able to create a user, right? So when you go to create a user, they get their information gets put into this file. If one of these fields has a colon in it, the user can't be created. So you don't have to worry about extra colons kicking around, which is nice because that actually really complicates the problem. If you look here, though, right, you do have to worry about spaces. Similarly, you might have to worry about a space in the user home directory, and you might have to worry about a space in the user login shell. It would be weird, but it's not impossible that these 2 fields have spaces in them. That's going to complicate things as well, as you'll see. OK, now you can read line-oriented data in many, many, many different ways, right? So this one is colon delimited. So it looks like it's an ideal candidate for strtok, right? The tokenizer function. That should be scanf. So I'm going to show you scanf later. But I want to use that strtok function to try to read one of these password files. Okay, so let's take a look at that. Close. All right, so password.c. You've got this. There's a link. There's a zip file on the OnQ that has this. That has all the source code in it. So the first thing I want to do is I need to store all the information that's in a line, right? So I'm going to create a structure for it. So that struct is going to be called record, right? The first field, or the first member, I guess, is the username. It's just going to be in order, right? So username, password, user ID, group ID, user information, home directory, shell, right? So most of these are strings, right? The username, password are strings. The user and group IDs, these are unsigned integer numbers. Right? So there's my structure for holding a record. Right? Now, let's go down to the main function to see how this thing works. Right? So the main function, I'm just going to open up the password file for reading. Right? If you try to open it up for writing and you don't have system administrator privileges, that won't work. Right? I'm going to create so this is a little dangerous here. I'm going to assume each line has no more than 100 characters in it. That works on my computer for sure. It may not work on every computer, right? In particular, because that user information field can be arbitrarily long. So you have to be a little bit careful about that buffer size. But now I'm just going to read each line, and then I'm going to read the record with this parse record function, right? And then I'm going to print the record using the print record function, right? So all it's going to do is just read the password file and spit out the information from the password file. Printing a record is relatively straightforward, right? So to print a record, I know what the type of each field is, right? So it's easy to use printf to output the file, to output each piece of information in the record, right? So the username, password, GCOS, home dir, and shell, these are all strings, right? And the user ID and group ID are both integers, unsigned integers, right? So it's easy to print the record. Reading the record is another story. So here's the function that actually tries to read one line of that file, right? So I'm going to read the file. I'm going to read one line into a string. I'm now going to try to parse that string, right? So that's the input string, S, okay? First thing I do is I make a record, or a record struct, right? If you want to, you can use a pointer to a record here and use malloc to allocate space for it. You don't have to. So here I'm just going to create a record instead of a pointer to a record. And now I'm going to call our tokenizer function, passing in the string, right? So the string and its delimiter, right? So remember the first time you call strtok, you pass in the string and the delimiter, right? Every other call where you're parsing a line or where you're parsing the string, you're going to pass in null, right? So remember, string tokenizer is this weird function that keeps state between each function call. OK, so I'm going to try to read the username. Right? And remember, this function returns a pointer to the start of the string, where if it finds the username. Right? So if it doesn't find the username, right, then it's just going to return the empty record. Right? Now, if it does find the record, it's going to copy that string into the username field of the record. Right? So copy string is going to copy that string, right, into that string here. But notice that I'm passing in the address of that string. And the reason I have to do that is because in the record, right, that's just a naked pointer, right? So there's no array that's allocated to the username at the moment, right? So I make a record, all of these are null. There's no actual storage. So I have to make storage for the username, right? Which means, right? Now remember how you make storage for the username, right? Somewhere you want to call malloc, right? And you want to assign the array that you allocate to username, right? So normally you would write username equals malloc, right? So that's the normal way you would do it. Malloc blah something, right? Now the problem is I'm in a function now, right? So I'm calling this function copy string that's going to copy it into this array, right? It's not just going to copy into the array, it's actually going to make that array. So in other words, I need to assign a value to our username, right? So what I really want to do is I want to write our username here equals blah, right? But I can't do that because I don't get the record. All I get is a pointer. All I'm going to get is the string that I'm going to store it in, right? So if I was just given the string, right, you would declare it as car star dest, right? Dest is the string, right? I actually want to assign that pointer to something. So I need a pointer to a pointer in this case, right? Because what I'm going to do is I'm going to allocate space for the string, right? So I'm going to allocate space for the string here, right? And then I want to assign that value back to the actual array username, our username. Right? So in other words, I want to change what that array, what this value here, I want to change what that actually points to, right? So you need a pointer to a pointer to do that, right? So I need to dereference that pointer, which is star dest, right? Star dest is now that thing there, right? It's now the username, right? Which I can now assign to the array, right? If you don't pass in a pointer to a pointer up here, right? And all you do, so for example, if you do that, and then you do this, right? And then you do this, right? So remember how C works. C works by pass by value, right? So I pass a pointer up to here, right? I then set the pointer to equal the new array, right? And then you copy the elements of source into the array, right? But remember that what that is, right? So if you only pass in when you pass in a value here, right, you don't get the actual, all you get is the address of the, so all you get is the pointer up here, sorry. All you get is the pointer up here, right? I actually need to change what that pointer refers to, right? So this is the same thing as we did with swap, right? If you wanted to swap two values, right? So remember when you wanted to swap two ints? Right? If you wrote swap like that, it doesn't work. Right? You can't, that doesn't actually swap x and y that the user passes in. If you want to swap x and y, you have to pass in pointers. Whoops, sorry. Right? This is the same thing. I actually want to make a new array and assign it to the make a new array and assign it to the variable. Right? So I have to pass in a pointer to a pointer in this case. Right? Or a pointer to an array if that makes things easier for you. Right? So that needs to be a pointer to a pointer or a pointer to an array. And then you need to, everywhere you need the actual array, you have to dereference the pointer to the pointer. Right? Okay, so this is, you're just going to repeat yourself every time. Right? So if I can read in the username, I'll copy the username from the string. Right? Then if I can read in the password, I'll copy the password into the string. Right? If I can read in the user ID, I will copy. In this case, I'm not copying. This one I can do straight assignment. Right? So I have the record. I have the field for the record, the user ID, so I can do straight assignment here. Right? So I can convert the string to an int and put that back into the user ID. Right? I'll try to read in the group ID and do the same. Oh, hey, there's a bug. Group ID, right? And store the group ID. I'll try to read in the user information, store the user information, right? And then the home dir, and then the login shell, right? Every time something fails, you just return the record up to that point, right? And you let the person, whoever called the function deal with what happens if a field is missing in the record. And at the end, you return the completed record. Okay, so does that actually work? I need a, where's here? Okay, so I have to recompile that, sorry. Okay, so does it work? It looks like it sort of works. Kind of, sort of. Right. So it definitely worked for root, right? So root has what appears to be the right information. If you actually open up the password file, you can look it up, right? That seems to be right. This seems to be right. That seems to be right. If you keep on going a little bit, though, you'll shortly see something that doesn't quite look right. Oh, right there. That does not look right. Right. The GCOS field for message bus says it's /non-existent. But /non-existent is actually the home directory for the message bus. So the message bus user. Right? So if you scroll back to here, wrong file, sorry. Cat, there we go. Here it is. Right? So there's the message bus entry in the file, right? You'll see right there, right? You've got two colons beside each other. So there's a missing field here. And it's the user ID, it's the user information field that's missing. Right? Now remember how string tokenizer works, right? So string tokenizer goes in and when it gets to the 106, right? So when it sees the 106 colon, and there's another colon, right? So remember what tokenizer does, it replaces that colon with /0, right? So that gives you the 106. And then the next time you call it, it starts from here, right? But that's a colon, so it ignores it, right? And it goes on to the rest of the string, which is /non-existent. Right? So it misses the missing token here. Right? And what ends up happening is you end up calling string toke one too many times, right? Which is why you get junk here in the shell, right? You get gibberish here. So that actually runs off the end of the string. So we got unlucky in this case. It didn't crash, right? Instead, the string tokenizer function went off, grabbed some random stuff, and stuck it into the shell field, right? And we happen to be lucky that there was a null terminator somewhere in that memory, right? And so that one gets messed up, right? And you can see that any entry that has a missing user information field also get screwed up. Right? So that doesn't quite work, but it's close. Whoops. Okay, so this is what's going on when you look at an empty GCOS field, right? So this is the picture I just showed you. So when you parse this string with string toke, right, it starts at the front of the string. S starts at the front of the string, right? It consumes the first token and replaces the colon with a /0, right? And then it keeps on going, right, every time you call it. So that colon gets replaced with a /0. That colon gets replaced with a /0. That colon and that colon all get replaced with /0, right? So when you correctly get the group ID here, 1000, right? When you try to go to the next token, so the user information, right, it sees the colon, and so it keeps on going. So it incorrectly reads in the home directory as the user information. So what you need to do in this case, if you know that there could be stuff missing, right, when you get to this point here, right, you need to determine, is the user information field empty or not, right? The way you're going to do that is you're going to look for that colon after that /0. Right? The rest of it's safe to do because the rest of this string can't be empty, right? So there has to be something after that /0, right, if this is a valid password file. So you can safely look at that character without worrying about running off the end of the string. Right? So string token, that function fails in this case because there can be empty, that user information field can be empty. Right? So now you can get around that problem if you can check for the empty GCOS field. Right? So that's password 2. That shows you how to do that. So everything's the same as before, right? Except now there's an extra function called isGCOS empty. Right? So you pass it in a string. Now remember, the string you're passing in is, or the pointer that you're passing in is this one right here. Right? So I'm going to read in the group ID field. S is still pointing to the start of the group ID field. Right? I'm going to use S. I'm going to pass that in to the function isGCOS empty to determine if that character there is a colon or not. Right? So how does that work? Well, I can get the length of the string. Right? That works because of the way string tokenizer works. Right? Because it replaces that first colon with the /0. So the length of the string is 4. Right? So that's 4. I'm going to put an insert statement in to make sure when I was first programming this, I put this assert statement in to make sure that I was interpreting all of this information correctly. Right? I want to make sure that the character at S length is in fact the null terminator. Right? So in other words, I want to make sure that that null terminator is in fact there. Right? So S4 is 1, 2, 3, 4. So it looks like that ought to be the null terminator, right? If I'm interpreting how string tokenizer actually works correctly, right? And then finally, I can check if that GCOS field is missing by looking at the next character, right? So S length plus 1, right? Is that equal to the colon or not? If it's equal to the colon, I know the GCOS field is empty, right? If it's not equal to the colon, I can assume that the GCOS field is not empty. Right? So when we get to the point where I read in the GCOS field, right, I can check, is it empty? If it's not empty, right, go ahead and copy it in. Right? Go ahead and call string token one more time. Right? Copy it into the GCOS field. Right? If it is empty, right, I know that the GCOS field is empty, so I can copy in the empty string into the GCOS field. Right? And then carry on. Right? And then read in the home dir, and then read in the shell, and so on and so on and so forth. Right? So if we run that, right? Now remember what we were getting up here, right? We were getting this weird hula DA, right? So when you run that, everything seems to work correctly. Right? So it looks like every line is parsed correctly, right? Anywhere where there's an empty user information field, it appears to be empty. right? And all the other information appears to be intact, right? So you can't always use using the string tokenizer function that comes in the standard library is doable. But it really only works when the information in your file is well behaved, right? When things like missing fields appear, you have to do extra effort. You have to put in extra effort to make this thing work, right? Now, this gets a lot more complicated if any field can be empty, right? So if any field can be empty, I'm not sure there's a good way to use string tokenizer to solve this problem, right? It becomes a bit of a mess. All right, any questions so far? OK. So instead of using this string toke, we can use Scanf to tokenize the string. Right? So Scanf is the formatted string scanning function. Right? So it uses a format string like printf does. Right? So remember, printf uses a bunch of percent conversion, converts values using a conversion character. Right, so %s converts a string, %d converts an int, and so on and so on and so forth. Scanf works the same way. Right, so you can convert part of a string or a part of a string using a conversion and store that into a variable. When you use this function, you can convert more than one thing at a time. So you can potentially convert the whole line in one shot. Right? When you do that, so whenever you use Scanf, it returns the number of tokens that are successfully converted. Right? Now, if the first token is not successfully converted, but there is something actually in the string, you get 0. Right? And it stops after an unsuccessful conversion. Okay? So for example, if you try to convert a string ABC with %d, right? So try to convert that as an int, it doesn't work. Right? You get back 0 as the result. If your string is empty, you get back a negative value, right? So you get back EOF, whatever that happens to be, and that's defined to be some negative integer value. Okay, now the conversions with Scanf are, you have to be careful with them because Scanf works in a very particular way. Right? So most of the conversions will consume and discard all leading white space characters. Right? So if you have a string, so if you got a string with a bunch of white space and then ABC, right, and you try to convert that string using %s, right, it will eat up all the white space and throw it away, and you'll get back the string ABC. Right? Similarly, if you try to convert something that looks like that with %d, right, it'll eat up all the white space, and it'll give you the 1. Right? So most of these conversions consume the white space. Right? If you need the white space, right, so if you need to read in a string and you want to keep the white space, you kind of have to use one of these two instead. So you either have to convert the string character by character, right, which means you're going to need a loop to read in all the contents of the whole string, or you have to use this funny bracket thing that I'll show you in a second. Okay, now these conversions, they're going to store the results into a variable somewhere, right? So if you're reading in a string, remember when you read in a string, you have to be careful that you have space, enough space to store the string, right? So you're allowed to specify the maximum field width after the % sign, right? So the maximum field width is equal to the maximum number of characters that the function will consume when it tries to do the conversion, right? So for example, if you wrote %5 %5s, right, it will consume at most 5 characters, not including white space, to attempt to read in that string. Right? When it reads in that string, right, it'll write, where to go? It'll write the null terminator at the end of the string. Right? So your maximum field width has to be at least width plus 1 characters. Right? Sorry, the amount of space that you have in your array to store the string has to be at least width plus 1 characters long, right? Where width is the maximum field width. Right? So when you're converting strings, it's normal that you put in the maximum number of characters that you want to store in the string before the s. Okay, so what is this funny square bracket notation? So the square bracket notation is you can put in any characters you want into the square brackets. Right? So percent square bracket stuff matches any non-empty sequence of characters from that set of characters. Right? So percent square bracket ABC will match any string made up of the characters A, B, and C. Right? So it'll match A, it'll match B, it'll match C, it'll match CBA, AAA, BBB, CCC, right? As long as it only consists of A, B's, and C's, it will match that string. If you use the caret in front of the set, it'll match stuff that's not in the set. Right? So not A, B, C will match any non-empty string that does not include the letters A, B, or C. Right? And this one turns out to be useful, as you'll see in a second. Right? So the problem with strings is that, especially when you read in a text file, is that a lot of text files, so the problem with using Scanf is that it stops converting at a space. So if you have a string that's got a space in it, and you want the space, right, Scanf won't do it for you if you use %s, right, because it stops reading at the end, at the space that's in the string. Right? Now, in a lot of file formats, so a lot of plain text file formats, strings will be enclosed in double quotes. Right? And so you can consume everything, including the double quotes, right, using that thing there. Right? So you can have a string, it's got double quotes, it's got spaces inside the string. Right? You can match that string using that kind of ugly notation there. Right? So when you see this the first time, it's like, what on earth is going on? Right? But if you take it apart piece by piece, it's not too bad. Right? So slash double quote, right? So remember, I have a string, right? So that's what the first double quote and the last double quote, that marks the that marks the limits of the string literal, right? If you want to put a double quote inside of a double quoted string, you have to escape it, right? So backslash double quote, that'll match the opening double quote, right? Percent square brackets, right? Caret means match anything that's not a double quote, right? So any sequence of characters that does not include the double quote, right? So that's everything after the opening quote, right? Again, you have to escape the double quote, right? Because it's inside of a double quoted string, right? Followed by the closing double quote, right? So this will match a double quoted string. All right, so let's take a look at the demo program first. Oops. Okay, so here's a little demo program. It's just going to try to match. It matches a bunch of strings. The strings consist of either strings or int value or unsigned int values. Okay. So here's how you use Scanf. Right? So the first string that you pass in, that's the string that you want to parse. Right? The second string is the conversion string. Everything else is a pointer to storage. Right? Pointer to storage. So I'm going to try to parse the empty string. I want to extract a string from the empty string, and I want to store the results in that string there. Right? So n, right, Scanf returns the number of conversions that it successfully completed. Right? So if I try to convert the empty string using %s, it fails. Right? You're going to get 0 here. Oops, sorry. Right? So we get you're not going to get 0. Sorry, you get -1. So you get -1 here because the string is empty. Sorry. Right? So you end up returning EOF, which happens to be -1 on this computer. Okay, this is the exact same thing, except now I'm going to try to parse a string with only spaces in it. Right? I'm going to try to convert it using %s. Now remember, %s eats up any leading white space. right? So it consumes all the leading white space and throws it away. You end up with the empty string, which gives you the same result as the first one. Right? So we should get back a -1 here as well, right? So the second one is also -1. Third one. So now I'm going to scan a non-blank string, right? So I'm going to scan the string ABC. I'm going to try to extract a string from that, and I'm going to store it in str1. Right? So this one works. So I should get 1. I should get the string ABC here. And we do. Right? OK. Now, what happens if I specify the maximum width? Right? So here it's the same string, ABC. This time I'm going to read at maximum 2 characters from the string. Right? So at most this is going to read the AB and store the AB in str1. The C is still sitting here. So if you had more conversions after this, you can read in the C. Right? So the 2, that's the maximum field width. Right? So here I should get AB, which I do. Right? Still 1 conversion. OK. Now I've got ABC space XYZ. Right? Here I've got 2 conversions. Right? The first one's a conversion of a string, but I'm going to read at most 2 characters. Right? The second conversion is a second string. Right? The first string will go into str1. The second one will go into str2. Right? If this works, I should get n equals 2. Right? Now remember, I'm going to read only 2 characters for str1, so I'm going to get AB. The rest of the string is still sitting there. So when I convert the next one, I'm only going to get the C, right? Because there's a space after the C. And that is, in fact, what you get. Right? Next one, so now I'm going to drop the maximum field width. Right? So when I parse that string, that will parse into 2 separate strings because of the space. Right? So %s will give me ABC in str1 and XYZ into str2. Right? Now, this one's got a 1 in the middle. Right? Sorry, it's got a 1, which I want to read into an int, which I've called x1 up here. Right? So I want to store that in the variable x1. Where are we? OK. So my conversion is going to be %s, %u, %s. Right? String, unsigned string. Right? Store the first string in here. Store the unsigned value in x1. But I have to pass in the address of x1. Right? Because I need to write into x1. Right? So remember, the function needs a pointer to the variable x1. Right? So that I can actually write into x1 from the function. Right? So remember, you're calling a function here, right, that needs to touch a local variable here. Right? The only way you can do that is by passing in a pointer to the local variable. Right? So you have to pass in the address of x1 and then string 2. Right? You don't have to pass in the address for string 1 and string 2, right, because they're arrays. So it can write into the array. Right? Scanf doesn't try to allocate space for the arrays. So you're not passing in pointers to the arrays. So that one should give you ABC1 XYZ, which I think it does. Here, yes. Right? So string 1 is ABC, string 2 is XYZ, and x1 is 1. OK, here's the square bracket conversion. Right? So this is going to, we've got the string here. Right? I'm going to try to match one string consisting of all lowercase letter ABC. Right? Followed by another string consisting of all uppercase letter ABC. Right? So the first string should be that, and the second string should be that. Right? Which it is. Right? And finally, here's that quote, that double quote delimited string having spaces in it. Right? So here's my string. It's going to be 100. Followed by a colon, followed by some string with spaces, followed by a colon, followed by no spaces. Right? OK, so this one I'm going to match as follows. Right? I'm going to match a colon, so it's going to match the opening colon. Right? Then whatever follows, I'm going to try to convert that as an unsigned int, right? So that should be 100. I'm going to store that into x1, right? Then there's going to be a colon. So there's that colon. Then I'm going to try to match this double-quoted string that might have spaces in it, right? Which is all here, right? And I'm going to store that in str1. Then I'm going to match another colon, which is here. And then I'm going to match another string, which hopefully is that, right? And that should go into str2. And if I've done everything correctly, that should all print out the way you expect it to, and it does. Right? So it finds three things. It finds the number 100. It finds a string, which is the string with spaces. And then it finds a second string, which is the string no spaces. If you, yeah, that's fine. Right? All right. Password 3, right? Password 3, yeah, OK. So now we can try parsing that password file using scanf, right? And I'm going to try to do it all in one shot, which you can do like that, right? So I'll explain that in a second. It's a bit funny. The conversion characters in it are a bit funny. OK, now when I make the record, right? Here I'm not using that string copy function that I had when I used the string tokenizer. So here I have to allocate space for all of the strings myself. Right? So for the username, the password, the user information, home dir, and shell fields, right? I have to allocate strings using malloc myself in this case. Right? And now I'm going to try to call scanf reading in one of these strings. Right? So the first field is a string of some kind, right? Does not include the colon, right? So I'm going to match. Now each one of these, that's 64, right? So at most I can read in 63 characters, right? What am I going to read in? I'm going to read in anything that's not a colon, right? So caret colon, match anything that's not a colon, right? Then get the colon. So that's the delimiter for the first field. Right, so that should give me my username. The next one should give me my password, right? The exact same thing, right? The next one should give me the user ID, then the group ID, then the gcos field, right? The user information, then the login, the home directory, then the login shell, right? When you store the information, you plunk it straight into the string in the record, right? So that's the username. There's your password. User ID, that's a number, so I need to pass in the address, right? So that's an int. Group ID, I need to pass in the address, right? And so on and so on and so forth. Right? That's a lot shorter than the string tokenizer version, right? Does it work? Password 3. OK, so let's see. Password 3. OK, so it reads in the first record fine. Reads in the second record fine. And it looks pretty good, right? Until you get to message bus again, right? The same one that had a problem from before, right? So you can see that it's stopping when it gets to the gcos field, right? It's not filling in the home dir or the shell, right? So it's stopping when it tries to when it gets to the gcos field, right? And anything that has a missing gcos field, you get the same result, right? No home dir, no shell, no home dir, no shell, right? So there's a problem here as well, right? So like the string tokenizer approach, right? That version of scanf doesn't work, right? So when a field is empty, right? That thing, the conversion that I used, this one here, that can't match the empty string, right? That's going to try to read in something, right? That does not include the colon, right? It has to read in something. It can't read in nothing, right? Otherwise the matching stops, right? So I have to do the same thing. I now need a way to detect, is there an empty field, right? So that's password 4. Fortunately, it's not that hard to do, right? So I know that the user information field might be empty. Everything else is not supposed to be empty in the password file. So I can read in everything up to, but not including, the user information field. Right? So that's the username, password, user ID, group ID, %n. %n returns the number of characters that have been converted so far. Right? So that %n there is the conversion that returns the number of characters that have been read. Right? So I'm going to use that to then look if the GCOS field is empty or not. Right? So %n I'm going to store into this variable called carsRead, right? Which is right here. Right? Okay, now remember scanf also returns the number of tokens that have been converted. Right? So if I don't get 4, something's wrong with my file. Right? I'm missing the username, password, group ID, or user ID. Right? So if one of those is missing, I can simply return the record and let the person deal with the fact that the entry is incorrect. Now I want to check, is that GCOS field empty? Well, I know the number of characters that are read. Right? S is just the string. Right? It's the pointer to the start of the string. So scarsRead, right? That's the next character waiting to be read. Right? If the next character waiting to be read is the colon, I know that the GCOS field is empty. Right? So make sure you set the GCOS field to the empty string. How do you set it to the empty string? You have to put in the null terminator at the beginning. Right? Now I'm going to move S. Right? Because I can't use, because S currently points to the beginning of the string. So I now have to move S to point to the next character that I want to read. Right? So start of the string, plus the number of characters I've read so far, plus 1 to get past the colon. Right? Now I can read in the home dir and shell. Right? If the GCOS field isn't empty, well, that's fine. Right? Advance S, right? So that I put it at the start of the GCOS field. Then read in the GCOS field, the home dir, and the shell. Right? And away you go. So this version works. Right? But like the string tokenizer example, it relies on one, that there's only one missing field, right? So that's the GCOS field. And 2, it relies on that there's only one missing field, right? And then you have to write something that checks whether or not the field is missing, right? Sorry. Where did it go? Here we go. Oh. Okay. Now, both of these examples, you should, when you look at them, you should sort of think that these are both kind of fragile, right? So we're assuming that only one field might be missing, right? If there's a missing field, we have to do something to check whether or not the field is missing and then proceed. Usually this approach doesn't work in real life. So the problem is often there's often the case that there's missing data in a file, right? And you need some other way to parse the file, right? So the other way to do this is to parse the file a character at a time, right? So use scanf to read in a single character at a time, right? And now when you're reading in a single character at a time, you're always checking, do I have a field delimiter or not, right? So in other words, do I see 2 colons side by side? In which case I know that that particular field is missing, right? If you're reading in a comma-separated file, do you see 2 commas side by side, or 2 commas separated only by spaces, right? So in general, when you parse, right, you're doing something like checking whether or not you're looking for the number. You're checking whether or not fields are missing, right? Unless you're willing to assume that the file you have does not contain missing data, right? That almost never works in real life. It doesn't even work in the password file, which is probably one of the most important files that's sitting on your Linux computer, right? So parsing is it's not hard. It's just very tedious, right? It's extremely tedious. I guess that's it for today. Anybody have any questions? Anybody? All right. See you on Wednesday. Okay.